Hello guys, welcome back to What Is. We are back with the topic of space. In the last video, we gave you a brief description about neutron stars. In this video, we will give a detailed explanation about them. In this, we will be answering the following questions. The first one, what exactly are neutron stars? The second one, how are they formed? The third one, how dense are they? So, let us get right in. Okay, so what are neutron stars? So, in order to understand how a neutron star is formed, I will need to give you a basic idea about a star's life. All the stars in the universe have nearly the same life until they reach the red giant phase. A star works on two main forces, gravity and the fusion of hydrogen into helium. Gravity tries to collapse the star on its own weight. The counteraction is provided by the fusion of hydrogen into helium, which prevents the star from collapsing under its own gravity. As the star ages, the hydrogen supplies start running out. This reduces the counteraction to gravity. The core collapses on itself and becomes a very dense and tiny spot. Due to the enormous amounts of energy released while the core collapsed on itself, the star's outer layers are pushed into space. The stars are then called red giants. The red giants are huge but relatively colder. This is because they seem to be huge due to the layers of dust thrown off, but in fact they have a small core. Anyway, moving on, a flurry of fusions happened in the core of the star. Helium, which was fused by hydrogen in the early life of the star, is fused into carbon. Then carbon is converted to neon. Neon is converted to oxygen. Oxygen to silicon. Silicon to iron. When the core of a star is finally fused into iron, the core stops fusing because iron is a stable metal and requires a lot of heat to fuse. After the fusion stops, the star collapses yet again and uses all of its energy, so that the temperature reaches 100 billion degrees. Like I told earlier, these sorts of fusions work against gravity. As a result of this great fusion, the outer layers of the star are thrown away into space with a vigorous force. Then occurs an explosion called supernova. So basically, after all the dust after the supernova have blasted right off into space, what remains is the tiny dense core. This is the time when the fate of the star is decided. If the weight of the core is in between 1.4 to 3 solar masses, then it forms a neutron star. Also, if the mass is greater than 3 solar masses, it forms a black hole. This is because the more the weight, the more the gravity of that object. So if the core is heavy, then it collapses under its own weight and becomes a black hole. Want to know more about black holes? Stay tuned for our next video. So now, let us get to our last question of this video. How dense are these neutron stars? I have been mentioning that these cores are dense. That would make the neutron star dense as well. But how dense is the question. Now, if you are wondering what makes the star so dense, I will give you a practical example. Just imagine the regular star to be an elephant, and then it collapses on itself and becomes the size of an ant, but without losing any weight. Just imagine this. The ant would weigh 6,350 kilograms. So, if our sun, which is 1.4 million kilometers in diameter, were to collapse and become an average sized neutron star, it would become just 20 kilometers in diameter, but with the exact same weight. Now that is dense. To give a small scale example, 1 teaspoon of our sun would weigh 2 kilograms, but 1 teaspoon of any neutron star would weigh anywhere between 1 billion to 6 billion tons. Now we come to the end of our video, but with some facts, of course. Fact number 1. Neutron stars rotate fast after they are formed due to all the energy they give off. The fastest one known to us is the PSR J174824446 AD. It is known to rotate 716 times per second. Fact number 2. The Milky Way galaxy alone has 100 million neutron stars. What would be the weight of the Milky Way then? 100 million weight of neutron stars plus weight of planets plus weight of other stars plus the list is never ending. So what do you think? Let us know in the comments below. Fact number 3. Neutron stars can host planets. Of all the neutron stars discovered so far, 2 of the stars have planets, though the origin is unknown. We think that they might be original planets that survived the star's expanding and compressing cycle. So guys, we hope you enjoyed the video. Hit the subscribe button and the bell for notifications. Also, follow us on Instagram not to miss any updates. Also, we are ready for any collaborations and sponsors. For that, you can mail us or DM us on Instagram. Stay tuned and thank you guys for watching.